guys, we're here on the Jeffrey roof to learn about slope. Now slope can apply to a lot of things, okay? But a lot of situations in life. But some of the best ways to visualize it is as a straight line like the slope of a roof. In class we did a project on roller coasters and did some slope of a line in roller coasters. So today I'm up here playing golf on the roof, right? Quarantine time, we're all going a little stir crazy at the house, so why not, right? So if you notice, this side of the roof has a positive slope. So the ball's gonna have to go up the roof to get to the top of the positive slope. And the other side of the roof has a negative slope, right? And we're gonna go down that side of the roof. So a line is going up, so it's rising as we go further in the run. Has a positive slope, and a line that goes down that's going negative rise over the run has a negative slope. So let's play a little golf.
Alright guys, this is what the side of my house looks like, where we were just playing golf, right? And you guys see that the total distance across my house, okay, is 32 feet, okay? But the distance that goes from where we were starting to play golf down here and where the peak of the roof, where the ball goes, stops going up and starts going down, that distance is going to be half of 32. So I know that is 32 divided by 2 is 16, okay? Now, the distance from kind of where that horizontal line is and the peak of the roof is 6 feet. Okay, so if I'm in my attic standing on the ceiling in my house, it's 6 feet to the very tip top of the roof. Okay? So I'm going to go ahead and assign values here. And I'm going to go ahead and say, okay, well, the distance going across my roof, my run, as it were, okay, is going to be my X value. And then the distance going up vertically here, that's going to be my Y value. So this point right here where we're starting off is at the point 0, because we haven't gone any feet across the roof, and 8. And I know you guys are saying, hey, why is it at 8 and not at 0, right? Well, notice it is 8 feet off the ground. Okay, so this is 8 feet off the ground. Now, the point at the peak of the roof, that's going to be at 16 feet for my run, right? Because we've gone 16 feet. And then the top of the roof is at 14 feet. And I know you're saying, well, I thought you said it was 6 feet. Well, there's 8 feet from the ground to the roof line, to where the ceiling is in my house. And then there's another 6 feet to the peak of my roof. So 8 plus 6 is 14. Now, I can go ahead and put those values here on a table, right? So I have my X values over here and my Y values over here. And that's usually how we do things. We're always going to say X first and then Y. X and then Y, right? I've got my independent variable X, the number of feet we've gone across the roof. And then I've got my dependent variable Y, the height off the ground, right? And I've got my first point, 0, 8. And I've got my second point, 16, 14, right? You guys see where that is? Now, what I want to do is I want to find my rise, right? The pink here, how much we've gone up, divided by my run, the distance we've gone across. So I can do that by saying, hey, look, I've got 14 minus 8, right? 14 minus 8 is 6, right? And 16, right? 16 minus 0, right, is going to give me 16. And notice I had to keep my points together, right? So I've got my green point here, which is at the peak of the roof, and I've got my yellow oranges point, which is at the where we're starting off, right? So I said 14 minus 8 gives me 6, and 16 minus 0 gives me 16, right? So my slope for this roof is actually 3 over 8, okay? So it's 3 over 8, right? And actually, if I want to write this, the equation of this line, right, it's y, my dependent variable, is equal to 3/8, right, my slope, see where my slope is here, x, which is my independent variable, the number of feet we've gone across the roof, plus 8. And why are we saying plus 8 here, right? Well, we're saying plus 8 because our starting point is already 8 feet off the ground, right? So my y-intercept here is going to be 8. When x is 0, y is 8. So at the end of my equation here, we're going to add that constant. We're going to add that 8 in there. Here's this line, right? And we talked about the peak of the roof. The peak of the roof at the top is this point 16, 14, right? And then my line at the bottom of the roof, right? The bottom, not the bottom of where the roof is 0, 8, right? So I have this point at 0, 8. So I count up 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now I need to find, I've got my slope of 3 over 8. So let's see if it actually is. So I'm going to count over 1, 2, 3, 4, 5, 6, 7, 8, and then I'm going to count up 1, 2, 3. And what do you know? That point is on my line, right? That point is on my line, and it is my point of 8, 11. Okay? And I know you guys are saying, I thought you just said 3. So, but really, let's look at it. 8 plus 3, 8, 9, 10, 11, right? So then I'm going to go over another 1, 2, 3, 4, 5, 6, 7, 8, and I go up 1, 2, 3, and there I am at my point of 16, 14, right? And I can see here, sometimes I like to draw like a little triangle just to look and see if my slope is actually what I think my slope is. So I drew a line right here that is 3 long, right? 1, 2, 3. And then I'm going to draw a line that is, so my rise is 3. So I need to make sure that's what's on the top of my slope over here is that 3, right? And then my run, my distance that goes across, should be 8. So I draw my line and I go 1, 2, 3, 4, 5, 6, 7, 8. And there we go. It's 3 over 8. Now let's look at the other side of the house. The side when the golf ball is going down. Okay? So if we look at it, we still have that 32 feet that goes across the house, right? But we're going to be looking at the second half of it. Okay? We're going to be looking at the part that goes from the pitch of the roof to the backyard. Okay? From the pitch of the roof to the backyard. Because we were golfing into the backyard. I didn't want to hit a golf ball in the street. Okay? So I've got my 16 feet in the back, and I still have my 6 feet going up, right? I still have my 6 feet that goes up. But here, we're going the opposite direction, right? So I've got my point at the back, right, which is 32 over 8, right? 32 and 8, right? And I still have that point at the pitch of the roof, the top of the roof, which is going to be the peak of the roof, which is going to be 16, 14, right? And so I can put those on the same table. I can say 32, my x value, my distance from where the golf ball started. And then the height at the back of the house is still 8 feet, right? And then this is actually the same point we were using in the last one, which is the peak of the roof, which is where the golf ball goes over. It's 16, 14. Okay, so 14 over 16. See how I kept them together again? And the y value goes on the top because that's the rise, how tall it is. and 16 is the run, how far we've gone across. Okay, so 14 minus 8, because that's the height at the end, over 16 minus 32. And now some of you guys are saying, oh no, we can't minus 16 from 32. Well, we can. It's going to give us a negative value. Okay, so 16 minus 32 is negative 16. Instead of being a positive 16, it's a negative 16. But then at the top, I've got 14 minus 8 is going to give me my 6. Right? So I have 6 over negative 16. And you guys see this is a fraction, right? And it's the same fraction we were looking at before, and it reduces down because if I divide 6 by 2, I divide negative 16 by 2, I get the negative fraction, negative 3 over 8. Okay? Now, if I want to write the equation to this line, I've actually got to calculate what the y-intercept is. Because at this point where we're starting off, that line would actually be starting way up here in the trees, right? And I went in and calculated that. You don't need to know how to find the y-intercept when it's not given to you until next year. So I'm going to let your teachers next year show you guys how to do that. In this situation, the equation for this line is y is equal to negative 3 over 8x plus 20. Okay? Because you're starting if we kept drawing that line all the way up here, this line on the side of my house would have to be 20 feet tall. And really, it's only 8 feet tall, so you would never actually see it. Okay? Now, here's our green line we just drew, right? Our green line with our positive slope. And there's the pitch of the roof, right? 16 with 14, right? 16 feet across and 14 feet from the ground, right? And here's that table, 16, 14, right? And here's our slope again, where we calculated our slope, right? So we've got that end point, 32, 8, right? And I can go back from 32, and I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, and then I'm going to go up 1, 2, 3, right? And so that point is going to be 24, 11. And I know we want to say like, hey, how come we got 24 here? Well, what is 32 minus 8? 32 minus 8 is going to give me 24, right? So we're subtracting, and then because it's going down, we're going backwards here, right? And then here I've got 16, 14, that same point we were in, okay? So here we're just going to draw our little triangle again, right? So we went to go from 24, right? We're going down 3, right? You see how this is going down from the green point, down 3, and we're going across 1, 2, 3, 4, 5, 6, 7, 8, right? And so that's how we get our slope of negative 3 over 8. So you guys see here, it's going to be going up at a slope of 3 over 8, and then it's going to be going down at a slope of 3 over 8, right? It goes up at 3 over 8. It's going to go up that 6 feet and across that 16, and then down that 6 feet and down that 16. All right, you guys stay safe out there. We never actually got it in the bucket there in the backyard. Take care.